welcome to another episode of Funny Philosophy. Now, this one's going to be a bit different in the sense that I am talking about philosophy, but this is more of a kind of jamming philosophy video, really, because I'm talking about the subject of space, as in outer space or internal space. Space in general, like in terms of just space. It could be outer space, the imagination, internal space or external space. So this should be interesting because I don't, apart from in terms of like philosophers who talk specifically about the universe, there are examples you can think of, or thinkers, Carl Sagan being one, cosmologists, and Spinoza, I suppose. So let's start. So as we've progressed, as the human race has progressed through time, we've become more aware of our own place in the universe, which proves to us that we are actually quite as individuals, we're insignificant dots in a vastly complex, incredibly large, and by all accounts incredibly entropic universe. And entropy is a principle in science which is universal. Everything tends towards disorder at a given enough time. So you start from a state of order, and then complexity continues, and all systems eventually go into a kind of decay. So this can obviously be quite a depressing realization once you realize that this entropy probably can't be reversed. I mean, there is such a thing as extropy, I think, which is about ideas around reversing entropy, but I'm kind of getting ahead of myself now. So there's many different angles I can approach this from, I suppose. Like, what relationship do we as individuals have to space? Well, it's very, for most of us, it's a very abstract one. Few of us are, like a tiny percentage of people have been in space as astronauts or cosmonauts, and it remains quite an abstract idea for the majority of us. I mean, some of us might be stargazers. I know I like particularly looking at stars on a clear night, but that's everyone's done that since every human being's really been drawn to those to stars since time immemorial, really. There's nothing unique in that specifically. I mean, we're made of stars. It's a cliche, but it's very true. I mean, the elements that compose us are stars. So, in a very profound and deep and meaningful way, that we are star stuff. Which Carl Sagan in his series Cosmos, which I recommend highly, talks about a lot. He also talks about the links between culture, religion, and cosmology as well. So it's an interesting series. I'd recommend that. There's a Neil deGrasse Tyson version as well, which is a newer version of Cosmos. But I'd recommend just watching both, to be honest. It's on Netflix, Cosmos, the newer one, and then you can find all the older episodes on YouTube. But that kind of gives a good introduction to the, I guess you could call it philosophy as cosmos, but which would be cosmology essentially these days. And all sciences root from philosophy in one way or another, anyway. So yeah, I mean, approaches to space. I mean, some people think it's a waste of time to invest in space exploration because they think it's like because it will take us, I don't know how many light years it takes us to get to the nearest solar system or galaxy, but it's a lot of time, and basically by the time you come back, everyone you knew would be dead because of the effects of relativity. So, for example, if you left at going at the speed of light, and it would still take you ages to get to the planet, the nearest solar system, but by the time you get back to Earth, if the time that's passed for Earth will be a lot more than has passed for you because you're traveling at light speed. It's the effects of relativity. So that kind of, but then I kind of think, I mean, we've been clever enough to invent aeroplanes. We've been clever enough to invent computing systems which can compute vastly faster than human beings can do. So I don't really see that as a barrier to researching space exploration. And to be honest, at the end of the day, we actually need space exploration if you want to survive or go beyond, another 1,000 years, a few hundred years, because at the end of the day, limited resources. The planet has limited resources, so if we don't, and yeah, it doesn't essentially mean becoming kind of space miners, I suppose, but that's kind of the future we've got in the far future anyway, is that we're going to have to mine off planet and for resources and traverse the stars, as it were, because if we don't, all we face is just a post-apocalyptic age of some sort of great falling down of, as resources dwindle, wars will inevitably happen, because most wars realistically are fought for resource and territory. Most wars are fought for. So if you can eliminate this, I'm essentially going into a Star Trek kind of society talking point, I suppose. But unless we mine the resources which we can on other planets and somehow find a way of being able to travel as fast as we need to, whether it be through Einstein Rosen Bridges or some other method of like wormholes, or punching some kind of hole in time and space, which sounds dangerous, probably is.
As time goes forward, let's just draw time going forward like that. The Einstein-Rosen bridge grows. It started with the horizons touching each other. It started. Let's draw it this way. Right over here, the horizons are touching. That's what happens as you move in, you get to this point over here, that's right over here, and then you go out the other end. Okay. At that point, at time t equals 0, the Einstein-Rosen bridge is as short as it can be. As time goes forward, the horizons start to separate. The two horizons of the two black holes start to separate and leave between them a region of space. So what does that look like? That looks like this thing starts to grow. It starts to stretch. It doesn't shrink, but it starts to stretch. If you work out Einstein's equations, you will discover that the solution grows and grows and grows. And in fact, in going from up here to across here, it's infinitely far, way up in these corners here, way up in these corners. So as time goes forward, this Einstein-Rosen bridge grows. Its growth is one of the reasons that you have such a hard time sending a signal completely through the Einstein-Rosen bridge. You can't, and it's because as you're trying to send a signal through, it's growing. And it's growing fast. It grows basically with the speed of light.
Yeah, way up to, lad. I'm just going to punch a hole in the universe and hope nothing bad happens. It's quite interesting actually around CERN, the atom smasher. A lot of people seem to have fears around that, creating a black hole or an infinite singularity, which were unfounded really when they were searching for the Higgs boson. But I digress. So yeah, I think realistically, it's my opinion, I think we need to become some kind of spacefaring civilization. Michio Kaku actually talks about this in his very good book Parallel Worlds, where he talks about type 1 civilization, type 2 civilization, type 3 civilization. So type 1 civilization can basically use the sun as a kind of energy source and is already spacefaring. Type 2 I think is exploration beyond our solar system, I think. So you can, and the type 3 is like a universe traversing civilization that can travel vast distances very fast and all the rest of it. It's hard to talk about this kind of thing without really referring to science fiction, because even though that's theory, but a science fiction because science fiction exists as the only real medium, I suppose, that we can kind of think about these big ideas. There's a lot of space operas and such which have been written around space exploration and space-faring civilizations. So, what are some of the risks, I suppose, associated with space exploration? Well, I mean, obviously, you could argue that we can't. Human nature is very contradictory, and human nature is, by its nature, it's contradictory, and it's also complex. And this often leads to, ideologies which develop, which then become ingrained within the human imagination, if you will. Like, so whether it be communism, whether it be Nazism, whether it be, Mark capital, whatever. Like, I mean, kind of these systems become their own reality tunnels, if you will, to use Anton Wilson's analogy of reality tunnels, which I won't bother going to explain now, but Google it if you're interested. And I guess one risk is that we just basically expand our territories, and then we have new territories. We've got advanced technology, and then you get new empires popping up who are warring against each other and stuff. Kind of like Dune, I suppose, the science fiction novel by oh, slipped on my tongue actually. Frank Herbert. So it'll be the bad scenario would be like Dune, where there's this kind of psychedelic resource which has a lot of different uses and can be used for space travel, and I'm going to a random one now, but then there's lots of competing empires and houses like competing for it. So it could just be, really, if you go start becoming a spacefaring civilization, it could just become the same shit.
A beginning is a very delicate time. Know then that it is the year 10,191. The known universe is ruled by the Padishah Emperor Shaddam IV, my father. In this time, the most precious substance in the universe is the spice melange. The spice extends life. The spice expands consciousness. The spice is vital to space travel. The Spacing Guild and its navigators, who the spice has mutated over 4,000 years, use the orange spice gas, which gives them the ability to fold space. That is, travel to any part of the universe without moving. Oh yes, I forgot to tell you. The spice exists on only one planet in the entire universe. A desolate, dry planet with vast deserts. Hidden away within the rocks of these deserts are a people known as the Fremen, who have long held a prophecy that a man would come, a Messiah, who would lead them to true freedom. The planet is Arrakis, also known as Dune.
Different, bigger arena, really, in terms of humanity. I mean, I'd like to hope that humanity could evolve to a kind of peaceful age of cooperation with ourselves and, potential other alien species and stuff. History has never really bared that out. But then we don't have to be tied to our history necessarily as human beings, but I don't know. That's a big question. I haven't got time to answer that one. So yeah, I don't really buy any. I think it's one of those questions that's like, we've got no choice. We've got to really invest in this thing. We've got to try at least invest in, because otherwise, what is all our endeavours of science and thinking being for, if not to prolong our own existence? It's a very big thing in science, medical science, whatever. I mean, obviously science technology can destroy us as well. Look at the nuclear bomb, for example, physics. But physics has also developed many different methods of helping human beings. So it's a double-edged sword, really. But I never buy this argument that when people say it's a waste of money, we need to concentrate on this planet. It's like, no, we can do both. We need to do both. We need to concentrate less on this kind of insane consumption idea of like insane consumer society where it's just consume. We have to sustain as well, and then explore further in barriers into out of space. So talking about I guess I was going to jump now. So spacefaring endeavours have often been culture war endeavours as well. So obviously during the Cold War you had the Soviet Union and America were the big two world powers vying for dominance of the skies, and that was Yuri Gagarin. So the Soviets won that in terms of the first person up there. This Yuri Gagarin he's one of my heroes, actually, to be honest. I've actually shared a birthday with him, funnily enough. Well, I've not yet been into space, but probably have the same smile. No, I don't have the same smile. That's it.
Yes, I can assure you there were no butterflies, moths, or anything else in my stomach.
Yeah, so he's the first man in space. First man to mission to space. Oh, sorry, my door's blown open. I knew that would happen eventually. First man mission to space. He came back and survived as well, which is good. There was a dog that Soviets sent up to space as well, Lykia. But unfortunately she burned up in the atmosphere, which is a shame. It's quite unethical in a lot of ways, but it's history, unfortunately. A lot of science in the past has been unethical, and don't know what else to say about that, really. So there's a culture war between the USSR and this is all quite obvious stuff, obviously, but I'm just going to floating around. So a lot of technological progress gets driven by cultural competitiveness, I suppose. That could well happen now because China's on the ascent still, really. Even though they don't have real human rights and they don't have developed human rights, and they don't have, in a lot of ways, they're kind of a state capitalist society, really. They're a centralised state, free market society. But I don't know if they've even got a space program. Actually, there's someone I don't know. But you'd assume that, because I guess a lot of the times the culture wars, or space wars, whatever you want to call it, emerge because it's only really you need a lot of money to invest in it, really, and it's so that's why the conflict arises usually between different competing powers. So the US is still powerful, obviously. Russia, I think, have got quite a decent space program. Well, Russia have always had a decent space program, really. So is USA, and obviously with NASA. Still the international space. I'm rambling too much now, so I'm going to change the subject. Actually, on something a bit more philosophical because I'm just kind of regurgitating history now. So I've already talked about potential ways you could get around that speed of light barrier. Only theoretical, and I'm not a physicist. I've only read about some of this stuff as a kind of interested person, really. From as far as I understand it, you can possibility of an Einstein-Rosen Bridge. Maybe there's some way of like teleporting. But then there's an interesting one. This is a really philosophical thing with teleportation as well. They say with teleportation, if you teleport yourself, are you creating basically a copy of yourself, and what happens to your soul during that process? So it's, like Star Trek. Say you've got like the transporter, and you get transported down to the planet below. Now, obviously, the first challenge within that is not having it so you fall to pieces when you go on the other side, because your atomic structure needs to be in exactly the same as it was when you started off from the initial A point to B point. So you need to be restructured and back into the same order. Otherwise, it's going to be a fly kind of scenario, and you're just going to be like, which wouldn't be nice. So there's a lot of technical challenges with that, obviously, to get around in terms of scientific understanding and all the rest of it. And then how would you even map the coordinates out? That's one thing as well. It's like, if you don't know where you're transporting to, then how can you possibly know how to, transport that information, as it were? It's an information transfer process, essentially. Sorry, this wind is annoying me as hell. So it's an information transfer process. So you're transferring information, the information being the atomic structure, and then you're reordering it on the other side. But unless you've got very specific coordinates about how that's going to happen, how can you possibly do it? So if you're going to an unknown territory, so in terms of like how we can explore the cosmos, even if we have sufficiently advanced technology, there's still going to come with complications, because you'd have to map out you'd have to map out the coordinates of where you're going first before you can actually go there, as it were. So in a lot of ways, it's like it's the final frontier. Cliche, obviously, Star Trek, whatever. But it's true. I mean, it's cliches exist for a reason, and I mean, it is the final frontier for us, as far as we know. Well, that's another thing. So obviously, our universe is expanding into something. We don't know what it is, but it's expanding, and we can tell that because of the redshift phenomenon. So the universe is expanding. It has been expanding since the Big Bang, which is the beginning of the universe. Spoiler alert. But we're expanding into something. Now, something that I've even stroked my beard about since I was like a teenager, really, is I had a little bit of wispy moustache hair on my face, was, well, what are we expanding into? That's a head messer. What are we actually expanding into? And because obviously we think of space as empty, and it is. I mean, it's not a void. People often think it's a void, but space isn't a void. It's composed of dark energy, dark matter. Obviously, there's things in it floating around, debris and stuff. But it's not a void. It's not empty in the truest sense of the word. Which, well, if you come to think of it, what is the truest sense of the word of void? I guess it's zero. But I mean, that's an interesting question, actually. Because if space is nothing, well, space isn't nothing, though. We know that because there has to be dark matter in the universe for the universe to even work. So there is some kind of weird invisible matter there in the universe, whereas it wouldn't be as it is. So yeah, space is a mind messer, really. Messes your head. So we've got 2 more minutes. So I've talked about mining as we'll probably become some kind of spacefaring mining civilization, I suppose. I think the only way it can really become peaceful is to have some kind of world governance or world organisation that kind of looks over everything, or is it kind of sets the standards for how we navigate space and how we kind of figure our way through the cosmos, I suppose. So yeah, Star Trek basically. So you watch 20 minutes just for me to come to the conclusion that basically we need to make Star Trek real. So I apologise for that. But it's true. I mean, there's something in Star Trek, and obviously Gene Roddenberry was writing that he was writing Star Trek as kind of a potential future society, so it makes sense. It makes sense. Yeah, basically done the 20 minutes now, so I'll shut up in T minus 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Shut up!
The lives and deaths of the stars seem impossibly remote from human experience, and yet we're related in the most intimate way to their life cycles. The very matter that makes us up was generated long ago and far away in red giant stars. A blade of grass, as Walt Whitman said, is the journey work of the stars. The formation of the solar system may have been triggered by a nearby supernova explosion. After the sun turned on, its ultraviolet light poured into our atmosphere, its warmth generated lightning, and these energy sources sparked the origin of life. Plants harvest sunlight, converting solar into chemical energy. We and the other animals are parasites on the plants, so we are, all of us, solar-powered. The evolution of life is driven by mutations. They're caused partly by natural radioactivity and cosmic rays, but they are both generated in the spectacular deaths of massive stars thousands of light years distant. Think of the sun's heat on your upturned face on a cloudless summer's day. From 150 million kilometers away, we recognize its power. What would we feel on its seething, self-luminous surface or immersed in its heart of nuclear fire? And yet, the sun is an ordinary, even a mediocre star. Our ancestors worshiped the sun, and they were far from foolish. It makes good sense to revere the sun and the stars, because we are their children. We have witnessed the life cycles of the stars. They are born, they mature, and then they die. As time goes on, there are more white dwarfs, more neutron stars, more black holes. The remains of the stars accumulate as the eons pass. But interstellar space also becomes progressively enriched in heavy elements, out of which form new generations of stars and planets, life and intelligence. The events in one star can influence a world halfway across the galaxy and 1 billion years in the future.